Good afternoon. Welcome to the afternoon session for the AWS Summits. Really appreciate you taking the time to join us here today. This session is deploy, manage, and scale your applications with OpsWorks and Beanstalk. And I'm Chris Barclay, product manager for OpsWorks, and joined here by my colleague Evan Brown, community manager for Beanstalk. And we're excited to tell you a little bit about our services today. So what are you going to learn in this session? We're going to first start and talk to you about the AWS services that help you manage, deploy, and scale your applications, namely Beanstalk and OpsWorks. We're going to show you a demonstration of how you can get your applications running on both Beanstalk and OpsWorks. And then finally, we're going to close the session with a discussion about using AWS CloudFormation as a means to document and version control and share your application configurations in a very reliable and robust way. So how many folks in the audience either create applications, deploy applications, or operate applications? Okay, that's kind of what I expected for folks that came here. And so many of you probably have been doing this for a while. This probably isn't the first day you've thought about applications. And at least back when I did more coding, I tended to do a lot of things by hand. I would log into my console screen, SSHN. I'd wget my software. I'd yum install stuff, and that worked pretty well for one VM or a server or two at a time. But it was really hard to get that predictable, right? It was hard to have a process that I knew happened in the same way every time. And if someone asked me to repeat all the steps that I did, I'd have to kind of look back through pages of notes and things like that. So it's always good to try to find a way to make your processes much more repeatable and reliable and be able to plan for failure. And of course, it's not just getting the software onto your instances, right? It's all about how do you manage when there might be problems or be able to understand the sorts of challenges that might be happening inside your infrastructure. So setting up proper alarms, being able to know what things are costing you. And so when you look at kind of operating and managing your application, it's a fairly big space. And what we want to do is give you tools that you can use to help manage your applications. And so Beanstalk and OpsWorks are two tools that AWS provides to help give you a little bit of a leg up and take away some of that, what we call undifferentiated heavy lifting that you'd have to do otherwise to have a nice, reliable, resilient application. So before I jump into the meat of the demonstrations, I want to tell you a little bit more about the services themselves. So for developers that want to just upload their code and have AWS take care of the rest, AWS Elastic Beanstalk is a nice service that supports containers such as Node.js, Ruby, Python, PHP, .NET, and allows you to very easily get your code up into the AWS services and leverage a lot of our underlying services like EC2 and autoscaling and elastic load balancing. If you're a developer that likes a little more control and you want to be able to customize your environment more, then OpsWorks is a nice solution that gives you automation and control of your application infrastructure and the ability to specify the layers and configuration of each of your components. And then CloudFormation helps you simplify the provisioning and management of your infrastructure. So I'll go ahead and turn it over to Evan to take you through Elastic Beanstalk.
Thank you, Chris. And just to echo Chris, thanks everyone for joining us this afternoon. So again, I'm Evan Brown. I work on the Elastic Beanstalk and CloudFormation teams. And Chris and I have both developed these two personas that we're going to talk about in the context of Elastic Beanstalk and CloudFormation, or OpsWorks and then CloudFormation. And so my persona for Beanstalk is Jane Doe. And Jane is a developer. So she builds applications, and these applications, sometimes they're web-facing front ends. They could be APIs. And then occasionally, Jane has the need to build apps that do background processing. So this could be sending an email asynchronously, generating a report like a PDF, things that don't really need to be in the request response lifecycle of a web application. So those are kind of the three big types of applications that she develops. She needs some flexibility to customize the environment that our application runs in. So when we think about environment customization, this is, I have a Java app or I have a PHP app, and I need to run that in Apache or in Tomcat, but I also need to install New Relic, for example, or some other system library. So she wants some degree of control over her environments. And above all else, she wants a simple API to deploy, manage, and scale these applications. So I'm going to kick things off with a demonstration. So we're going to do a day in the life of Jane deploying and managing a PHP application. So it's a simple PHP app that allows users to store text messages. The text messages are stored in a database. We're running the application in this example on Elastic Beanstalk, and Elastic Beanstalk gives us features like elastic load balancing, auto scaling, managing of our EC2 instances, and so on. So here's what we'll do in the demo. And the demo is about 15 minutes. I'm going to check the application out from GitHub. So this is in a public GitHub repo, so you all have access to it if you want to run your own web-based text messaging service. We're going to integrate this application with the EB command line tool. And so EB is a tool that we provide that integrates with Elastic Beanstalk, and it's really focused on developers who have workflows that may be command line based and also integrate with Git. So we'll talk about how this tool lifts your Git deployment workflow and integrates it into Elastic Beanstalk. We're going to deploy from the command line. We're going to view the console and manage it, and then we'll do some changes to the application. I wore my lucky green demo pants today, so I know the demo is going to go off without a hitch, just because of the pants. So I'm over here in GitHub, and we'll provide this link after the demo, and this is recorded, and the slides will be available. But I have this PHP sample application. I'm going to copy the URL, and I am going to go over into my directory, and I'm going to git clone the application locally. So we're sucking the commits or all of the application history locally, and I see that I've got my application here. That's good. So I talked about EB. EB is this command line tool. You can install it on Linux, Windows, or OS X. And with EB, the first thing I need to do is take this Git repository. I need to take my application, and I need to glue it to Elastic Beanstalk. I need to define what is the application, how should we deploy it. So EB init is the starting point here. And EB init is going to ask me for my credentials, so my AWS credentials, so I can talk to Elastic Beanstalk securely. Where would we like to deploy the application? I'm going to go ahead and deploy this to number 2, which is Oregon. I'm going to give the application a name. So this is Evan's demo app. And then we're going to deploy the application into an environment. So an environment is a load balancer, an EC2 instance, and a database, and all of those things. So demo app env is what's being suggested here. This is a web server that we're deploying as opposed to a worker, which is the other option. But we'll talk about the worker option in the slides here in just a moment. And we have the full list of all of the options that you've got with Elastic Beanstalk. And it's a long list, but these are sort of the types of applications, languages, and operating systems that you can choose to deploy. You see we've got Ruby, Python, Tomcat, Java, Windows Server, Node.js, and then up here is PHP 5.5. So that's option number 2. I will select that. Beanstalk or the EB tool rather, is asking me, how do you want to deploy this? We have the option of just a single instance. We'll talk about the use cases for single instance a little bit later. But I would like a fully load balanced and auto-scaled environment. So I'll choose option number 1. We would like an RDS database. So Beanstalk will provision and manage an RDS database for us. I don't have an existing snapshot or backup that I want to use. It's going to be a blank database. Password is password in this example. And if the database gets terminated, let's say we delete the environment, Beanstalk is asking, hey, should we do a backup of the database if you choose to delete the environment? And I think backups are good, so I'll take that. And then the instance profile, we'll get into that a little bit later as well. So at this point, my Git application on my laptop is configured to deploy to Elastic Beanstalk, but it's not actually deployed yet. So the next command that we want to run is EB start. So EB start says, get the application, deploy it to Beanstalk, and fire up the environment inside Beanstalk. And I'm not going to deploy the initial commit yet. We'll come back and do that here in just a bit. So right now, we're talking to Beanstalk and saying, give us a PHP environment, build it up so we can deploy an application. This isn't my first rodeo, and it's not my first cooking show. So I know that you don't put an unbaked pan of brownies into the oven without having another oven that you pull a perfectly baked pan of brownies out to show. So while this pan of brownies is baking, so this is demo app, we're going to look down at a pan of brownies that I baked this morning. So this is a fully deployed version, and the brownie should never be green, but this is our Beanstalk environment that I deployed earlier this morning. So now what we want to do is drill in and explore the console and do some deployments and some management of this existing application. So clicking that green box takes me into the environment. So the environment, again, is my load balancer, my auto-scaling group, my logs, all of my monitoring mechanisms. And Beanstalk uses the core infrastructure services that AWS provides, right? So EC2, it's managing EC2 instances, but they are real EC2 instances that are in your account, and you own them. We're just sort of distilling this API and saying, you're a web application developer, there's some things that you probably care about. And those things we can really kind of enumerate over here. The configuration of your app, the logs, the monitoring, the alarms, the health of the application, the version of the application that's running. So you notice that I've got my git commit, or the hash of the commit of the application that is running here. And I've got a nice friendly icon that lets me know. And then maybe most importantly is the link to the application. So Beanstalk creates a Route 53 DNS record for your application. And it lets you put a customized name on there. But if I were running this, if this was evansdemoapp.com, if I had that domain, I can, of course, slap that customized vanity license plate domain on top of Elastic Beanstalk, and so customize the experience there. So I'm going to click and open up the application, and this is actually exactly what I was expecting. So the application is built to sort of not work the first time. And this index page says in the last sentence that the demo app expects to run from the web document root, or the web directory. So who has changed the document root for a web application before? Show of hands. And then someone can shout out, what file do you normally have to change to modify the document root? And you can shout it. Apache, httpd.conf. Yeah. So you got the whole /etc/httpd. We don't want to SSH into these servers, right? So this particular application is actually running 2 servers in 2 different availability zones. I don't want to go look up the IP addresses of those servers and figure out the SSH key and then SSH in and modify a file. So this is sort of the first value proposition of Elastic Beanstalk, and that is, we know in this case it's a PHP application that you're running, and so we know there's some things that everyone wants to manage about a PHP application. So in the configuration panel for this particular environment, we have a number of different tiles, but I'm going to start with the software configuration tile. And this is where we say, we talk to PHP developers, we know the types of things that you need to control, so we're going to expose some of these common things in this higher level interface. And that first common thing is the document root. So I say /web is my document root, I click save. Beanstalk is then managing the EC2 instances behind the load balancer, and it is configuring them for us dynamically. It's editing the etc httpd.conf file for us. And then we'll use this as sort of a chance to dive a little bit deeper into what's happening behind the scenes. Beanstalk gives us an event log, and the event log is really the workflow, sort of what's happening right now. What is Beanstalk doing on my behalf? The event log goes back. We can control sort of the output level. This looks, if you've written to log files with a log tool before, these are info levels. And we see from the most recent event that it is updating the configuration settings for my environment. So I want to toggle back into configuration and talk about what you can do with your config inside this screen, and then we'll come back and look at the working application. So back inside of software configuration, we've got memory limit, if URL fopen is enabled, if PHP error should be disabled, max execution. So these are lifted up from the php.ini file or from the Apache file. Beanstalk also supports a one-click or a toggleable option for log aggregation, right? It's the same premise as editing a configuration file. You probably don't want to SSH into each server and find and manage and look at logs. It's just not convenient. So Beanstalk allows you to enable log rotation, and in this case, we'll automatically take logs every hour from all of the EC2 instances behind your environment, and we'll store them in S3. You can pull them down from S3 and grep through them. You can browse through them in the management console, and we'll take a look at the very end of the demo at some of the files that get pulled out of log rotation. And then finally, we have environment properties. So environment properties are environment variables that get injected or made available to your application running on the server. So the good example I like to use is if I'm using like New Relic or Loggly or some third-party service in my application code, and that third-party service requires an environment or requires credentials to connect to the service. Environment variables are a really good way to inject that secret information and make it available to the application. So I can customize the environment variables that are made available, and Beanstalk will push them out to all my services. So for example, I might have New Relic API key and some value. We'll look at a code sample here in a bit that shows how you would use Python, .NET, or Java to pull these values in from your application code. But the key premise here is we're not putting the New Relic API key or any other API key inside our source code that's being version controlled, because I don't want my New Relic API key in a public GitHub repository. I definitely don't want that to happen. So that is, let's flip back here. That is the software configuration bit. And back into the configuration tiles, there's two more tiles I want to talk about. The first is scaling. So the scaling tile allows us to control how our application is deployed. In the first example, whether or not it's load balanced or single instance, and we can toggle between these two modes, and Beanstalk will provision for us correctly. In a load balanced environment, it's pretty critical that you choose where your application is deployed. So how many data centers or availability zones. So what we're exposing here is just a very simple form to say, I want a minimum of 2 instances, I want a maximum of 2 instances, and this is a particular configuration that I chose for this application. How many zones do we want to deploy across? And then the scaling trigger. So if we say that the minimum is 2 and the maximum is 8, how do we grow and shrink? And again, it's one of those things that we shouldn't have to do manually. So this application, I've decided that it's CPU bound. So the indication that we need more servers is that CPU utilization is going up. So I've set the scaling trigger to average CPU percentage measured over 5 minutes. If that exceeds 70%, then I want to add 2 servers. So if CPU goes up, average of 70% across the 2 servers that I have, Beanstalk will add 2 more servers for me. Maybe equally important, especially if you're architecting an application with cost in mind, is you want to scale back in when you don't have excess load. So I've set a threshold here. This is somewhat arbitrary for this application, but if we're running at 40% or less CPU, let's take a server away. And it will continue to do that until we get to the minimum number of servers, 2. So we'll never go below that threshold. So this gives us this sort of number line to move around in as the CPU requirements or utilization of the application changes. And then one more thing in configuration, and we'll get back to the application, is we make it really simple to control the types of EC2 instances that are running here. So I've got M1 mediums, but if we wanted to run C3 larges or M3 larges, it's change the option, save the configuration, and Beanstalk will redeploy the application servers with those pieces in mind. You also do have the ability to enable SSH if you want to, and choose monitoring as well. So let's go back to the dashboard, and we're at green. So we see that our update changed. So we changed the document route. We should now see like the functional application running here. So I'm going to open this up, and this is what we expect to see. So this is our basic Your Thoughts application. I've been running a load tester on this, so we'll look at the load testing or talk about sort of the metrics that produces in a bit more detail. But if we want to share our thoughts, I'm good enough, I'm smart enough, and how does this end? Doggone it, people like me. That's a Saturday Night Live reference, my favorite Saturday Night Live skit. So we've saved this bit of information to a database. We're going to talk to the database, talk about the database piece here in just a bit. But now I want to cover the application update workflow. So I've decided that share your thought with an exclamation point is maybe just a bit much. So how do we change the application code? How do we develop locally, change locally, and then push these changes out into Elastic Beanstalk? So we're highlighting the EB tool here today. We'll talk about the other development workflows that are an option here in just a few minutes. But in the EB workflow, I'm going to open up TextMate. Drag this screen over here. There we go. Got it. So in the application source, I have this thing called app.php, and somewhere down here, I set up the code. So I'm going to say, penny for your thoughts. So that's the text that shows up. Remember, I'm using get. So if I do a get status, I see that source app.php has changed. I'm going to commit that locally. Is this being pushed out to Beanstalk now? No, we haven't done anything remote. We've done a local commit, but the EB command line tool, EB push, allows us to take this application, take the head commit from the local Git repository, bundle it up, and then we're going to send it out to Elastic Beanstalk. So if I Alt-Tab back to the console, here in very short order, we're going to see the environment go into updating. So we're doing the deployment of the code, or Beanstalk rather, is deploying all of the application servers and giving them the new version of code. So while the application update is happening, I want to talk a bit about data storage and how we integrate or interact with the relational database service in Elastic Beanstalk. So when I did EB init, when I initialized my application, I chose RDS. And that manifests itself again as a tile inside the configuration dashboard. And specifically, the RDS section gives us information about our database. And this says, well, your endpoint, your connection string is here. That's your port, that's your password, and then the specifics about the RDS database. And again, getting back to the, where you put credentials or configuration information, we don't want to put this information in our application source code. We don't even want to bundle it into a configuration file because these things could change. So I want to talk a bit about the conventions that Beanstalk uses to help you get access to this information. So toggling over to the Git repository here, looking at the source code, inside source, I've got a PHP file called dbconnect. And it's actually really straightforward. We inject, or we make, rather, this connection information available to your application as environment variables. So this server underscore server global allows us to pull environment variables from the host. So RDS DB name, RDS username, and RDS password are how we get this information out. And then there's one more challenge here. There's a bit of an elephant in the room regarding the database, at least I think. So when I launched the application, I said I started with a clean slate RDS database, right? It doesn't have anything on it. So what is, if you're building an app that writes to a database, what does the database need to have before the application can write to it? Schema. It's got to have a schema. So somewhere you have to run your create tables thing. This is another example of something that I could do manually. I could open up MySQL Workbench, connect to the database, and run some scripts. Beanstalk provides a convention, and I talked about Jane's requirement was to be able to exert some control, some customization over her environment. So there's another convention in Elastic Beanstalk, and that convention is this thing called .eb extensions. So if you put a .eb extensions directory along with your application at the top level, you have the ability to drop these little configuration files inside that directory. And these are YAML configuration files. And Beanstalk recognizes that they're special things, and it does special actions based on them. So I've written, or I've included rather, this database.config file in my application. And I'm telling for each server that the application is deployed to, I want the MySQL command line tools installed locally. And then I want a command executed. And here I'm saying, hey, Beanstalk, when this thing gets deployed, I want you to run deploy schema.sh. And the name is pretty indicative of what that script does, but I've included it inside the EB extensions directory, so this gets executed when my application is deployed. And create if not exists is important here. So this is a nice convention for, hey, I deploy my app my schema happens automatically. If you're doing a Rails application, you might do rake db migrate if you've done a schema change between deployments. But this gives you a nice, convenient, declarative way to customize all the software on the box, because it's your EC2 instance, to do things like database setup, but do it in a managed and version-controlled way. And this is something that we definitely want version-controlled. So as we make schema changes or we change the script, it rides along with our application deployment. So at this point, I think we've got I bet we have our application change deployed. I'm going to open up here, and I'm going to do a refresh. Of course. I didn't get Penny for your thoughts. Let's check the application version. So one other bit of control that Beanstalk gives us is the ability to manage which versions are deployed to the environment. So in this case, we have the version that I just updated or I just applied, and we see that it is deployed. I think I committed from the wrong directory, so I'll check on that in a bit. If we wanted to do a rollback, let's say we deployed something that didn't work, we can choose a previous version. We can go actions, deploy, choose our environment, and click deploy. A few more things in the environment section. So Beanstalk gives us the ability to pull logs. We can click the snapshot logs button here, and we'll have access to the log files. Probably my favorite way to do this is as part of my command line workflow. EB logs integrates with Beanstalk. It's aggregating the logs from the EC2 instances, bundling them up, and then here in just a few seconds, we'll see the output displayed on the screen. So you can pipe this to grep and search for things, and so we see that 2 instances pulled the log files. So those are all of the logs from Apache and PHP from my EC2 instances pulled down into my local workflow for me to do monitoring and analysis on. Finally, from the monitoring perspective, Beanstalk takes sort of all of the metrics that we collect for performance and EC2 and ELB. It takes these metrics and it puts them in a convenient dashboard. So I got up pretty early this morning and I ran some load tests or some load generation tools against this application, and I ran about 72,000 requests against the app. And we see over that 1-day period for 72,000 requests, average latency was 36.1 seconds. I've definitely over-provisioned the EC2 instance here because I'm running at a very low CPU utilization here. I would probably go back into the configuration page and change from an M1 medium to an M1 small. Because if I'm going to cost optimize, I want to know that I'm using the CPU that I'm paying for. So very easy to toggle between the EC2 instances, run some load tests against the app, and then use the metrics to decide what's appropriate for your particular application. So we really focused on the EB and sort of the PHP Git workflow, but Beanstalk does support Java, Python, Ruby, .NET, and Node.js, and it supports deploying those applications to 3 different environment types. So we've got the single instance environment. I use this for dev and test. For non-production or non-critical systems, this is just one EC2 instance. There's no load balancer. And I have the ability, if I decide, to grow it into a load balanced instance. But I maintain all the functionality around like pulling logs, monitoring, and the robust configuration. The environment that we launched and we demoed here was the load balanced and auto scaled. And we see that in the bottom, in the app tier, we're scaled across availability zones or physical data centers in this case, the US West 2 region in Portland. Beanstalk supports the 3rd environment type, and this is background task or asynchronous task handling. So the idea here is that you have in the upper left-hand corner, you have producers. Some application is generating work, and we're integrating or pushing that work into SQS, or the simple queue service. It's another Amazon service for message handling. And the queue delivers the application, or rather integrates with Elastic Beanstalk to send the messages to your applications. It gives you a very simple way to use PHP, Ruby, .NET, Node.js, Python to handle background task workflows. I talked about Git, but Beanstalk allows you to use the tools that you're comfortable with or that you know to deploy and manage. This could be a web browser in the console. This could be Eclipse. We have a plugin or a toolkit for both Eclipse and .NET, if those are your IDEs. And then, of course, the Git workflow that we discussed. But at the end of the day, the objective here is really to get your application, code deployed. There's an animation. It's a good animation. We can even do it one more time for free. I can write a PHP app in my sleep. Getting that stuff to line up, I was really proud of that. So creating app versions and then deploying those things back. Rolling back, right, we've got our application version history here. At any time, we can roll back the deployment and update it very easily. We talked about how you can customize your servers with the EB extensions directory. And we went over the database schema example specifically. In this example, I've got a configuration file where I'm actually putting environment variables in. And the environment variables here point to an S3 bucket where I've stored some secret information. So again, credentials, secrets, you don't want to commit those with your application. I'm storing them encrypted in S3. And then I'm setting an environment variable called API creds. And then in my application code, if it's a Python application, I can use os.environ.get API creds. And I'll give me the link to S3 to download and decrypt the credentials in my app. I can use system.get properties in Java or app settings in .NET or whatever application you deploy, however you access environment variables. That's sort of the convention that we really encourage folks to take when they build Beanstalk or build and deploy Beanstalk applications. I'll be back in a bit to talk about CloudFormation. Chris is going to talk about the OpsWorks persona next.
Thanks, Evan. So just kind of keeping everything in the family, Jane's brother Joe also does a lot of software development, but Joe is, has a little bit different needs than Jane. Joe, in contrast to Jane, really likes to build software with some pretty broad architectural patterns. So his apps come in a variety of shapes and sizes. He likes to throw in things like MongoDB for database layers, maybe his own HA proxy instead of using elastic load balancing. He likes to customize his instances a little bit more, and so he needs a high degree of freedom to be able to customize and really grow his app in whatever variety he wants. So let's talk a little bit about one of the aspects before I jump into the demo of OpsWorks that I think is pretty interesting. Who here has heard about Chef as a configuration management tool? Great. So OpsWorks includes support for Chef. And one of the things that it includes is the ability to run your Chef recipes either on demand or in response to certain events that happen inside your system. So you can run those recipes automatically. And one of the nice things about being able to run recipes automatically, of course, is that you can automate things. So we have a couple different lifecycle events that you can attach your Chef recipes to, and they'll get run whenever those events happen. So the first thing is a setup event. So when an instance boots up, a setup event gets fired, and so it runs setup recipes. So what might you want to run with that setup recipe? You might want to run like install Apache, install mod PHP. These are the sorts of things we're going to show you inside this demonstration. A configure event gets run whenever any instance boots up inside your stack. So a stack basically is all the resources you're using as part of your application. So why might you want to use configure? Well, let's say you have a load balancer like HA proxy. You probably want to be able to bring app servers in and out of that load balancer as they start up and when they get healthy. So that's what configure can do for you. Then, of course, deploy allows you to run recipes when you're deploying your application. You can run those recipes at any time, like I said, using execute recipes. And then you can attach recipes to a shutdown event. So if you wanted to clean up before you shut down, like maybe you need to finish processing some things on your worker tiers. So here I have an app server I'm going to be booting up. So my PHP app server, it boots up, it installs my PHP app server in this case. I deploy my application to it. And then Joe likes to have not only the CloudWatch monitoring metrics, but he runs a Ganglia server. So as part of our demonstration, we're going to boot up and install Ganglia on an EC2 instance as well. So when that Ganglia server starts up, that configure event is used to make sure that the PHP app server starts sending metrics to Ganglia. And Ganglia is ready to start receiving metrics from the PHP app server. So that's how we can really leverage these recipes so I'm not busily SSHing into my instances and doing things manually. Now when I deploy my application update again, that deploy event gets sent to all the instances in my stack. Now for the Ganglia, the deploy is basically a no-op, but there may be times when I actually want to do something with that deploy event. For example, maybe the first time I deploy an application, if I'm running, say, a Postgres layer in OpsWorks, I might want to create my database tables like Evan mentioned. So you can use those deploy events if you need to, and if you don't need them, then you can ignore them on any of your layers. Then if I start up another PHP app server, what's going to happen? Well, my setup events are going to happen. I'm going to be able to get the PHP installed on those that new instance as well, and then a configure event fires off. So that instance as well gets hooked up to communicate metrics that I've configured to my Ganglia server. And then if I want to run a specific recipe on demand, I can do that. So I might want to change user permissions. We'll talk a little bit in the demo about how you can have user-based SSH access to your instances. And so if I wanted to add a new user to my instances, then I can do that from basically one command click. And then, of course, if I stop my app server, I'll run those shutdown recipes, and a configure event goes out to my other instances as well. So hopefully that made a little bit of sense. We'll cover this in the demonstration, but just wanted to give you a little bit of an overview of the sorts of lifecycle events you can use to help automate the customization of your recipes. So for those of you that haven't seen Chef recipes, just a quick primer on what a Chef recipe looks like. Basically, there's a couple different components to a Chef recipe. The first is the recipe itself, which is expressed in a Ruby-type syntax. And here we have a recipe that basically represents the connection string, which I'll use to connect to my RDS database. And then we have some attributes that are referenced in the recipe. And so the attributes are passed in as metadata that kind of comes in as a JSON-type syntax to the recipe itself. And Chef takes care of decoding that for you, so you don't have to do any JSON parsing there. And so you can see that it pulls out the database username, password, and host name to stick into this recipe, and then a command gets executed at the end of it. So it's just a quick primer on what's happening underneath the covers. So we're going to use a similar demonstration and sample app as what Evan demonstrated or what Jane demonstrated to us. But this was also going to have Ganglia. So we'll take you through that demonstration here. Command tab?
Command tab, tab, tab.
Tab, tab, tab.
Tab,
Thank you.
tab.
I'm just learning how to use Mac today, guys. So here we go. Sorry, Windows user. So we have OpsWorks console, and so I'm going to do my demonstration through the console here. And the first thing I'm going to do is I'm going to go ahead and add a stack. So everything in OpsWorks that you're doing is all the resources you're using as part of your application or your service is done in the context of a stack. That's really kind of, think of that as the container around all the objects you're creating. So let's just go ahead and give it a name, my sample app. And we have a couple different options you can see here. We have things like, we can select the region, scroll.
Oh, 2 fingers and drag. Sorry.
I'm pretty dumb. So you can see we can select things like the region, availabilities, default availability zones, which we can override, and all sorts of goodness. One of the things that is probably most exciting is hostname theme. So we could be a little more exciting and select something like baked goods. Makes me hungry. And then let's go ahead and open up this advanced. And here's where you can choose your chef configuration. Sorry, everyone. So let's go ahead and we're going to use custom cookbooks because, as we mentioned, John really does like to customize. And so we have a couple of different repository type options. We can use Git, Subversion, archives on HTTP or S3. And in this case, we're going to just go ahead and GitHub's pretty convenient. So I have all my cookbooks here already for me. So why don't I go ahead and grab this URL. Go back over here. We'll paste it in. If I had a SSH key for my repository, I'd type it in there. But this is a public repo. And then we can see that I can add some custom Chef JSON. So you can use attributes that are inside your repository, or you can put those attributes in here as well. And seeing as how I don't really have any use for right now for any of these other customization options, I'm going to go ahead and add my stack. So the first thing I'm going to do is I'm going to add a layer. And a layer, think of a layer as a blueprint for your EC2 instances. So every instance you create inside a layer basically inherits all the properties that you've defined inside the layer. So let's go ahead and we'll create our first layer. And you can see we have a couple different predefined layers. So OpsWorks gives you some pre-built layer types you can choose. I'm going to choose PHP. And let's go ahead and add that. And let's go ahead and also go ahead and add our Ganglia layer. And you can see we also have this custom layer. And so custom layer lets you basically install and run any software you want. So whether that's MongoDB or Solar, Elasticsearch, any software that's out there, Chef has a pretty vibrant community of folks that are contributing to cookbooks. And so a lot of times you can grab cookbooks out of the open source. So for example, Tengen, the folks that manage MongoDB, have a very nice cookbook that works with OpsWorks. So you could run that under a custom layer. I'm going to go ahead and create my Ganglia layer. And let's edit our PHP app server layer to show you a little bit more about what's happening. So OpsWorks includes some built-in recipes that configure the built-in layers for you. So it gives you, out of the box, the functionality you'd expect for PHP. So it installs Apache, for example. It takes care of that Ganglia configuration. And if you're interested in taking a look at what any of these are, you can just click on them. And all of our cookbooks are available on GitHub as well. So feel free to fork them, give us pull requests. We appreciate the feedback from the user community. And then there's a place for you to put your own custom recipes. And you can see the lifecycle events that I mentioned. So if we wanted to, for example, configure our PHP app server to connect with a database, then I'd probably want to create some sort of recipe. And in fact, we have a recipe for that over here in our recipes area. We have our app setup recipe. And this basically takes care of getting the connection string and pushing it into my application. So again, I don't have to keep my my credentials inside my source repo, which is a good thing. So I go ahead and just add my PHP app recipe. And so now I'm basically extending a built-in layer. So I can extend a built-in layer, I can create a custom layer, or I can just use the layers as is. Once I'm able to actually figure out this trackpad. We can also choose an Elastic Load Balancer to use for this layer. And since I'm going to be scaling out my PHP app server, I'm going to go ahead and choose this Elastic Load Balancer so it'll route traffic to the instances that I create in this layer. We can see a couple other configuration options. And I feel like an idiot here with this.
You're trying to scroll down.
What's that?
Are you scrolling?
Sorry. Thought so.
The arrow keys will work too.
There we go. We can also attach EBS volume, so I could specify a volume and mount point. So if I wanted to attach a volume to, say, MNT data and specify RAID level 1, 10 gigabytes, I can select PIOPS version volume if I want, or just a standard one. OpsWorks will take care of doing that configuration. I can assign Elastic IP addresses if I wanted to each of these instances. I can specify additional OS packages that might need to be installed. So maybe I didn't have MySQL installed. I can select that. I can specify custom security groups. And then one nice little thing here is auto-healing. So OpsWorks is constantly communicating with your instances, or rather your instances are communicating with OpsWorks to see if there are events that it needs to take care of and run. And if your instances get in trouble and they're not communicating, they might be offline or have a problem, then OpsWorks can take care of restarting your instance for you, so auto-healing that instance. So that's basically the configuration settings for my PHP layer. So now why don't I go ahead and create some instances in these layers. So I'll go ahead and add a couple instances. So I have my cookie instance, and I can choose the instance type if I wanted. I'll add a Ganglia instance. And OpsWorks gives us some flexibility on being able to configure instances that are on all the time, or instances that are scaled for me as well. So why don't I go ahead and start these instances, and we can look at we have time and load-based instances as well. So if I wanted to create a time-based scaling policy, I could create an instance and then specify when that instance is supposed to run. So this is pretty nice for predictable loads. If you know that, for example, during the day you want to have a couple extra instances that come online, but you want to shut them down in the evening. And then, of course, you can create load-based policies as well that look a lot like what Evan was showing you in Elastic Beanstalk. So you have a couple different options, but every instance that you're creating that are associated with the layers basically get all the configuration details that you specified in the layer. So it runs the chef recipes at the time you specified. If you asked for volumes to be attached, it attaches creates a volume for you and attaches it in the mount point you specified. So a lot of the kind of heavy lifting that you'd have to do otherwise gets done for you automatically, and you have a lot of customization ability in that layer configuration. So like Evan, I've gone ahead and created a pre-baked demonstration, and so we'll go ahead and talk a little bit about applications. So I'm able to create one or more applications that get installed on my layers, and here I have an application just named My App. My application is on GitHub as well, and so I just pointed to this GitHub repo, and so you can see our repository URL. Why don't I go ahead and edit this app, and we can take a look at what I've done. I specify my document root, my repository URL, my branch and revision number, so I can update that and redeploy if I made any updates on my repository, and then additional settings like domains and SSL settings. And once I have my application, then I can go ahead and deploy it. So when I set up my deployment, I have a couple different options. So I can specify the instances that I want to deploy my application to. So if I wanted to do something like a one-box deploy, I could select just one application to deploy it to it first and see how that deployment goes with that application. Or I can go ahead and deploy it to everything. So I'll go ahead and kick off that deployment. And we can see that OpsWorks is taking care of checking or calling the recipes on my servers. The PHP recipe checks my code out of GitHub, so it does a get pull. It knows how to restart the PHP app server so that my application gets properly installed. And if we take a look at previous deployments here, or our deployments area, we can kind of see all the deployments, which user has run them, which command was actually run. So if I were to run a specific recipe, you could see that. And then, of course, inside the deployments, you can even see the logs for that. So I could see the chef run log if I'm interested. If there was any sort of problem or whatever, I can see that directly from the console. So I mentioned that you saw users here in the deployment, so you might be curious as to what users OpsWorks supports. So OpsWorks allows you to specify IAM users and what sort of permission levels they have. So I can basically say user Mary, who's on my team, is able to deploy apps, but I don't actually want her to change anything in this stack. Whereas our manage user will give that person manage privileges, and manage user is the only one who's allowed to SSH in, and we trust manage user a bit, so we'll give him sudo access as well. So I'm able to specify with a nice degree of granularity the sorts of control that the people on my team have with the resources inside my stack. So I can use this for delegated access, so you can give a specific user the ability to import other users and specify the roles that they might have in that particular application. And it gives you a lot of control over the types of things that people can do. And then, of course, if they're actually doing deployments, you can see which user has done it. And on the monitoring side, similar to what Evan showed you, we also have aggregated CloudWatch metrics. So I can see, for example, my PHP app server. This is all aggregated by layer. And then I can drill in and see specific servers themselves, and drill in to see a bunch of instance-based metrics. So I can see things like the CPU, the memory, the load of those servers, and these are all being collected by the agent that's running on the instances themselves. So that agent is what's allowing you to kind of execute recipes on demand and collect metrics for you. And let's go ahead and take a look at our application. So we have our Elastic Load Balancer. Tells me very nicely that I'm running my instances in just one availability zone, so I probably want to go ahead and start up something in another AZ, so I'll have a little bit higher resiliency. If I hit that, your thoughts, I'll get a very similar UI to what Evan showed us. But let's take a look at my Ganglia server as well, because we did want to show how we could customize and run a different type of layer than just a standard web app. So we have our Ganglia monitoring server. And I'm going to go ahead and log on here, and let's take a look at the metrics that Ganglia is collecting for me. So we can kind of see a bunch of graphs coming out here. We can see that my PHP app 1 server has been added. And if I were to start up another PHP app server, as I should, since we are only running on 1AZ, then that app server would be added as well if we were to have the time to wait for that to come up, which I'm not sure we do given the timing. So in summary, OpsWorks gives you a nice little capability of being able to have a little more customization through the layer configuration. And I'll go ahead and turn this back over to Evan to talk a bit about CloudFormation.
Awesome, thanks, Chris. So Chris mentioned in the very beginning these 3 services: Beanstalk, OpsWorks, and then CloudFormation. So CloudFormation, actually a show of hands, who has used CloudFormation before? Very nice. That's a good number. So CloudFormation is a service that allows you to model your not just your application, but also your environment. And this environment could include your VPC, so your networking. It could be RDS databases, Elasticache clusters, queues. But you get to model your entire application and infrastructure as a JSON document, so a template file, and then of course, you version control the template file. You check it into Git or Subversion or Perforce, and then you give that template file to CloudFormation, and it executes the APIs on your behalf. So it does orchestration. It knows the proper order to create things, and maybe just as valuable as it knows the proper order to delete things. So it allows you to manage from start to finish the provisioning of an entire application, an application stack. And then the other big thing that I really like about this is that it's repeatable. So the same template file can be shared with everyone on my development team, so we all have identical environments. If I decide to take this wicked Your Thoughts app, it's going to be big, and I want to move it to a European audience, and I want to deploy in the EU West region in Dublin, I can take my CloudFormation template file, give it to the endpoint in Dublin, and I get the exact same infrastructure stack. It's identical between deployments, because everyone knows this, if you do these things by hand, then they're different from every single time. Or when a person who builds the infrastructure leaves and takes a different job. When you've got CloudFormation, that's your documentation in a way of exactly how everything was built. So I said CloudFormation can create a lot of different AWS resources. I mentioned VPCs and EC2 instances and RDS databases. It can also define and provision an OpsWorks application or an Elastic Beanstalk application for you. So in this case, here's my Beanstalk environment for the Your Thoughts app. And next month, in my next sprint, I've got some items to add DynamoDB. So I want this application to start using Dynamo in addition to RDS. And I also want the application to provision an S3 bucket to store some images, and I'd like it to use identity and access management. So I could create all of these things by hand in the console, but when I want to do that again, or when I want every person on my team to do that, it's not going to be predictable. So rather than create these things by hand, I'm going to wrap them up in a template file. There's one more animation left. There it is. So we take our entire application and our infrastructure, and we model this as a template file. And then where do we store it? Version control. So we version control these things. So when I change the specifications for my Dynamo table, or I change security groups, I'm actually modifying a template file. I'm version controlling that. So I can look back at any point in time and say, oh, that's when we accidentally opened up port 22, or that's when we changed the size of the RDS database. And maybe even better, I can point the fingers at the people who did that. And I can use CloudFormation to roll it back. So create your stack, modify a template, update your stack. CloudFormation will execute the APIs. And then if it's a dev or test environment, delete your stack, and it will tear everything down for you. So now we're getting into the conclusion slides. So some of the things that we discussed, just to, what do they say? You tell them what you're going to tell them, then you tell them, and then you tell them what you told them. So this is the tell you what we told you part. Sort of how to choose or how to gauge which is correct maybe for your application, Beanstalk, OpsWorks, or CloudFormation. how to get an application running with both Beanstalk and OpsWorks, and then sort of where CloudFormation fits in for provisioning and managing resources. And again, those things include Beanstalk applications or Beanstalk environments. And then we've got two quick calls to action here. So we are going to start an office hours hangout. This is a 5-part series that we're launching on April 10th. And in this 5-part series, the title is Develop, Deploy, and Manage for Scale with Elastic Beanstalk and CloudFormation. So we've got this really beefy, it's a Tomcat or a Java application that uses Spring that's built inside of Elastic Beanstalk. And we're going to talk about sort of from step 0 all the way up to running and scaling this thing globally, how you do it. So that is, how do you write the CloudFormation templates? What are the best practices for how you use multiple templates? How do you do configuration management? How do you use CloudFormation to operate an environment? So this is getting out of the console a little bit and using that version-controlled, continuously integrated approach with CloudFormation. So that's the link. And then we're going to integrate OpsWorks into these office hours sessions as well. And so the office hours idea, right, is that we get on Hangouts and we're there for an hour. We have a topic. We usually have a blog post in a GitHub repo. And you have the material, you have the sample code. And so we'll be publishing the OpsWorks sessions in the application management blog as well. So with that said, I want to again thank everyone on behalf of myself and on behalf of Chris for coming out. We will be we're going straight to the booth right now to do booth duty. So we'll be there to answer all of your questions or take feedback on these services. We really love to hear that. And so look forward to interacting with you at the booth this afternoon. Thanks again, folks. Bye-bye.